Okay, so these are notes on trophic pyramids, and we're going to look at two different kinds, one biomass and one energy. And in your text, if you follow along in the book, you're going to find these in pages 386 to 389. And this is going to help to explain some of the patterns that we've been seeing when we looked at the meadow simulation and we looked at the carbon pools and we played the dice game. So the idea of a pyramid diagram is simply, right, we have this triangular or pyramid shape. We call it a pyramid diagram, even though it's, a triangle if you're in geometry. And on the bottom, there's more stuff, and on the top, there's less stuff. So we've seen this, as I said, in pretty much everything we've done in ecosystems. So we know, like, the producers are here on the bottom, then the primary consumers, then the secondary consumers, then the tertiary consumers. And so within an ecosystem, there are more producers than there are primary consumers, more primary consumers than secondary consumers. And we could even add in, if we wanted to, right, like I don't have this in here, but we could, right, this would be the soil carbon, exactly. So then down here you've got the most stuff, which would be the organic soil mass. Let me go back there. So if you look at a biomass pyramid, and this is pretty much what we saw at the end of the meadow simulation, right, that compares the dry mass of biotic organisms at each trophic level. And again, what's not on here, but we could put on here, this would be the soil, right? So this is the soil organisms and the dead stuff in the soil. And you'll notice this actually gives numbers. And so you'll notice that there's a 90% decrease or a 10%, I don't want to say transfer right now, but there's a 90% decrease in mass between each level as you go up. So, right, this should be 10,000 if you are counting soil, so 10,000 kilograms. And what that means is you need 1,000 kilograms of producers to sustain 100 kilograms of primary consumers. And if you go back to the carbon pool numbers that we were looking at the other day, you're going to notice that while it's not a perfect 10% every jump that you go, it's pretty close. And so, different ecosystems are going to have slightly different numbers just based on some unique characteristics, right? Biology is a little squishy that way, but you would notice about a 10% change every time you go up. It's not a 10%, it's a 90% decrease is what it really is. I'm trying to make this less mathy. I don't know why. All right. So then let's take a look at an energy pyramid. So actually, let me go back a second. So this is what we already knew, right? This is what we've been talking about all week. This is what we looked at in the meadow. This is what we looked at in the carbon pooling. This is what we looked at in the dice game. But now we're going to talk about why. So this pyramid, which is the exact same pyramid except looking at energy, explains why. And again, in here we don't have the soil, but there's actually a little bit of a reason for that. So, and the main reason is we're looking at trophic levels. So in an energy pyramid, we see that only 10% of the energy is transferred between trophic levels. Meaning, remember, trophic levels are about eating relationships. So what that means is, however much energy is here at the secondary consumer level, only about 10% of it gets transferred up here, which is why you have fewer organisms the higher up you go. In other words, you need 90% more primary producers to sustain a certain amount of primary consumers. Think about it this way as well. So like you have this bird here, right? This bird might weigh, I don't know, let's say 2 kilograms, okay? Over the course of its lifetime though, it's going to need more than 2 kilograms worth of primary producers. In fact, it's going to need 10 times that much to sustain itself. And this is why people talk about, if you eat a primarily vegetarian diet, that's why they talk about there being less energy loss. Because the higher up you eat, the more energy is lost every time you go up a trophic level. And so where does that energy go? It goes a couple of places. So one place it goes is to non-predatory deaths. So energy can only be transferred literally up the pyramid when it's eaten. If something's not eaten, then energy won't go up the pyramid. Which is why decomposers end up sort of outside the pyramid, because they're eating all of the non-predatory deaths. Or they're even maybe finishing some of the predatory deaths that weren't fully eaten. So like if a wolf brings down a deer, let's say, and eats 80% of that deer, well, who eats the other 20%? That would be the decomposers. That energy is not going up the trophic pyramid from deer to wolf. So that's one place. Another place is waste products. So if you remember, our waste products are all of the macromolecules that we don't digest. So those clearly aren't transferring their energy up the trophic pyramid. And so that's another place. But then the biggest place they go is the heat into kinetic energy, using the glucose, all of the heat for our body, all of the reactions we do, right? So right now I've eaten dinner and I'm recording notes and I'm using energy to do so. If on my way upstairs I'm mauled by a bear that eats me, it actually won't get any of the glucose that I am currently metabolizing to use for energy. And so again, the higher up you go, the more energy is lost. So if you think about it this way, right, 90% of, well, actually, let's say this, right, this is 10% of the energy is transferred between between the producers and the primary consumers, and then 10% is transferred between the primary consumers and the secondary consumers. But that means that 10% of 10%, which is 1%, is transferred from here. So that's a huge loss of energy as you're going up the trophic pyramid, which is why if you're eating down here, you are maximizing the energy that is lost to the ecosystem. Which again is why, and we're going to talk about this a little more as far as what you eat, especially when we eat the mealworms, and why it's important. So I also want to quickly talk about two contaminant issues. Okay, so in these pictures, you have blue are contaminants, okay? And so these are contaminants in the biosphere. They're called literally biocontaminants. These are things that humans tend to like pour into their waterways that then end up in the fish, that end up in the seals, that end up in the polar bears, or that end up in the stuff that we eat. And so one of them is bioaccumulation, and bioaccumulation is within a trophic level over time. So this is time here, meaning these three fish are the same three fish. This is just when they're little fish, and this is when they are older fish. And over time, contaminants will build up in them, simply because contaminants are things that our bodies can't get rid of. So our bodies are really good at getting rid of a lot of waste, and a lot of the things we don't need, but there are some things that our bodies aren't good at getting rid of. Heavy metals are one of those, so like mercury will build up in a human's body over time. And then also certain toxins and pesticides that are so new that our bodies haven't evolved to have a way of getting rid of them. Our bodies don't just know how to get rid of everything. There's different ways that our bodies get rid of different things. Like some are filtered by our liver, some are filtered by our kidneys, some are filtered by our lungs. And so there are contaminants out there that our bodies just haven't figured out how to get rid of yet because they're new in the scheme of things. And so over time, those things are going to build up in our bodies simply because if we keep putting them in, then there's nowhere for them to go. So then the second type of contamination, though, is biomagnification, and that's between trophic levels. So this is, right, the polar bear is eating the seal, which is eating the fish, which is eating the plankton. Okay? Now, because we understand that it's not one polar bear eating one seal, right? One polar bear needs to eat the equivalent of 10 times as many seals. Those contaminants get what are called magnified within organisms as you move up the trophic levels. So that's why something like mercury, which ends up sometimes in our waterways, that's why if you eat something like salmon, salmon is the equivalent of a secondary consumer. So it eats things like shrimp, which eat things like plankton. Okay, so salmon doesn't have a ton of contaminants, whereas tuna is equivalent to the polar bear. So tuna is like a quaternary and sometimes a quintenary level consumer. And so that's why people are told they shouldn't eat more than 1 or 2 cans of tuna a month because of those contaminants. Because tuna, and a lot of people don't know this because they're used to it coming in a little can, but tuna are actually these ginormous fish. Like, they're like 4 or 5 times the size of a salmon. And so they're eating a lot of stuff that's really high up on the trophic pyramid that has allowed things like mercury to magnify. So hopefully this now makes a lot more sense as to why the trophic pyramid is the shape it is and why you need more organisms on the bottom to support the organisms on the top. And then also how we actually see things like contamination moving between trophic levels and how it affects us. Please feel free to ask questions in class or email if you have them. Have a good night.